Given the function y equals 18 times secant of the quantity 12x plus 228 minus 4, we want to determine the period, horizontal shift, vertical shift, range, and also sketch the graph over one period. Notice the given form is in the expanded form, or the form shown above here. We normally use the form shown below, where the input for the secant function is in factored form. And therefore, let's begin by factoring 12 from 12x plus 228, which gives us y equals 18 times the secant of 12 times the quantity x plus 19 minus 4. Next, let's determine the values of a, b, c, and d in this form. Notice a is 18, b is 12. We need to be careful with c. The form has to be x minus c, and we have x plus 19. Recall x plus 19 is equivalent to x minus negative 19, which indicates c is negative 19. And d equals negative 4. Now let's determine the period. The period equals 2 pi divided by b, or the absolute value of b, which gives us 2 pi divided by 12, which is pi divided by 6, or if we want 1/6 pi. Next, the phase shift or horizontal shift is determined by the value of c, which is negative 19. Because c is less than 0, the function is shifted or translated left the absolute value of c units, or in our case, left 19 units. The vertical shift is determined by the value of d, which is negative 4. Because d is less than 0, the function is translated down the absolute value of d units, or in our case, down 4 units. And now let's determine the range. Recall the range for the basic secant function is from negative infinity to negative 1, closed on negative 1, union 1 to infinity, closed on 1. But because our graph is shifted down 4 units, and a is positive 18, it's going to change the range. Because the graph is shifted down 4 units, think of the y value starting at negative 4, and then because a equals 18, negative 4 minus 18 is negative 22, which means the range is going to be first from negative infinity to negative 22, including negative 22, union negative 4 plus 18 is 14. The second part is from 14 to infinity, closed on 14. If this is a little confusing, it'll become more clear once we graph the function over one period. So now let's focus on graphing the given secant function. Remember, when graphing a secant function, it's often helpful to sketch a related cosine function, which indicates we'll begin by graphing y equals 18 times cosine of 12 times the quantity x plus 19 minus 4. Notice for this cosine function, the amplitude is 18, the period, horizontal shift, and vertical shift are the same as the secant function. So let's begin by graphing the cosine function, starting at x equals negative 19, because the graph is shifted left 19 units. And then because the period is 1/6 pi, let's mark a point on the right as negative 19 plus 1/6 pi. And let's say we have a break in the horizontal axis, and then here we have the vertical axis. Because the graph is shifted down 4 units, we'll mark negative 4 on the vertical axis. This is where the midline will be. Let's sketch the horizontal line y equals negative 4. For the cosine function, because the amplitude is 18, and negative 4 plus 18 is 14, let's mark positive 14 on the vertical axis. And negative 4 minus 18 is negative 22. Let's mark negative 22 on the vertical axis. Notice 14 and negative 22 will be the max and min values for the related cosine function. Next, we'll break the period into 4 equal subintervals. So with the 4 subintervals, so we'll cut it in half and then cut it in half again. And now we'll follow the basic pattern for the cosine function when a is positive over this interval. Recall for the basic cosine function, the pattern is max, midline, min, midline, max. Which means at x equals negative 19, the function value is 14. Next we're at the midline, then the minimum of negative 22. midline, and max. Let's go ahead and sketch the related cosine function. Now remember, wherever the cosine function is at the midline, the related secant function will have a vertical asymptote. So we have vertical asymptotes here as well as here. From here, remember, the high points and low points on the related cosine function are also points on the related secant function. And wherever the cosine function is concave down, the related secant function is concave up. Which means we can now graph an accurate graph of the original secant function, which would look like this. Passes through this high point and approaches the vertical asymptote and is concave up. In the middle here, it's concave down and approaches the vertical asymptotes. And on the right, it's concave up and approaches the vertical asymptote. Of course, if we went or two, we could sketch more of the graph to the right, which would look like this, and on the left, it would look like this. Looking at the graph below, notice the range is negative infinity to negative 22, including negative 22. Union, looking above, the range is from 14 to infinity, including 14. And before we go, we can verify the graph using Desmos, which I've done here. I hope you found this helpful.